Let's take a look at some problems where we use the exponent rules to simplify expressions. In the first expression, I have a bunch of things multiplied together. This is all just multiplication. And so we can gather together the similar exponents and multiply the coefficients. Right, so negative 5 and 8. I can multiply those to get a negative 40 as the new coefficient. A times A is going to become a squared. B to the negative 3 times b to the positive 3, I want to add those exponents. And C is just all by itself, so that's going to be multiplied with everything else as well. So now this is 40a squared b to the 0 power times c, but b to the 0 power is always just equal to 1. Anything raised to the 0 power equals 1. So we have negative 40 a squared times 1 times c. And of course multiplying by 1 doesn't change the value of an expression, so negative 40 a squared times c is the simplified form. In the next problem we have a quotient, so we're going to divide the coefficients and we get 6, and we're going to subtract the corresponding exponents. So we have x to the 4th in the numerator, and I can subtract x to the 1st power from the denominator, so I can subtract 4 minus 1. Y to the negative 2nd minus 6, and z only appears in the denominator, so I could think of z to the 0 as being up in the numerator. Again, z to the 0 just equals 1. So then to subtract the exponents, I have z to the 0 minus negative 3. And so in the numerator of the expression, right, so this is now just all, like if I wanted to think of it, this is all like in the numerator of the expression. I have x to the 3rd power, y to the negative 8, and z to the positive 3 power. So we have 6 times x cubed times z cubed divided by y to the 8th power. So that would be the simplified form. The final expression here, we need to use the rule for distributing exponents. We can simplify the expression inside a little bit first, or we could distribute the exponent to every factor. If we simplify, the m's cancel because they're raised to the same power. This is m to the 1st power divided by m to the 1st power, but they leave a negative 1 behind. And then n to the 2nd power divided by n to the 5th power, we can subtract those exponents. And that then, that after we subtract it, that lives up in the numerator, at least for a moment. And finally, p is all by itself. So this becomes negative 1 times n to the negative 3 power times p, and all of that's raised to the negative 4th power. So we can distribute that negative 4 to each of the factors. So I have negative 1 to the negative 4th power, n to the negative 3 raised to the negative 4 becomes n to the positive 12. We multiply those two exponents. And finally p to the negative 4th power. So we can write this with a fraction to get rid of the negative exponents. N to the positive 12th is going to be in the numerator. I can think of this as negative 1 to the 4th and p to the 4th in the denominator. But because 4 is an even number, multiplying negative 1 with itself 4 times is going to cancel out the negative. Negative 1 times negative 1 is positive 1. And if we do that again, we get another positive 1. And so the simplified form is really just n to the 12th divided by p to the 4th.